Okay, so this is our second way to solve linear systems algebraically. The first way was using substitution, and this way is going to be using elimination. And what elimination is going to do is we are actually going to eliminate either our x variable or our y variable, and it doesn't matter which one. We just have to decide how it is we're going to go about doing that. So let's start off with an example. Let's say I have the linear system 2x plus y is equal to 1 and x minus y is equal to 2. So I have two lines. I've got line 1 or equation 1 and I've got line 2 or equation 2. And what we want to do is we want to find the point of intersection where those two lines are going to meet. Now, using elimination, what I want to do is I want to get rid of a variable, either my x's or my y's. Taking a look at these two equations, the easiest variables to get rid of are ones where the coefficients match. So if you look at the x's, the first x in equation 1 has a 2, and the x in equation 2 has a coefficient of 1. They don't match. Take a look at the y's. The coefficient in front of this y is a 1, and the coefficient in front of the second y is also a 1. So these are the variables I am going to eliminate for this particular system. Okay, so let's get started. When I eliminate the variables, I either add the two equations together or I subtract them to get rid of them. So we have to ask ourselves logically, if I have a plus y and I have a minus y, what am I going to do to make it so I have no more y's at all? Well, if I take equation 1 and I add it to equation 2, equation 1 plus equation 2, I'm going to add these two equations together, then let's see what the result turns out to be. I've got a 2x plus an x, and that's going to give me 3x's. And then I have a positive y plus a negative y, and that's going to eliminate my y's completely. Then I'm going to go over here, and I have a 1 plus a 2, which is going to give me a 3. And now I just solve for x. I'm going to divide both sides by 3, and x is going to turn out to be 1. I need to find out what the y value is, so I'm going to plug x equals 1 into either equation 1 or 2. It doesn't matter. You choose the 1. I'm going to plug it into 2, just for fun. And it's going to look like this. So where I used to write an x, I now can write a 1. And the minus y is still going to be there, and that's going to equal 2. I want to get the y by itself to find out what it is, so I'm going to subtract 1 on both sides. So I'm left with minus y is equal to 2 subtract 1, which is 1. This is a minus 1 in front of this y. We just don't write it in. And so I'm going to divide both sides by minus 1. And divide this by minus 1. And so therefore, I've got y is equal to 1 divided by minus 1, which is just negative 1. So therefore, I have a point of intersection at the points 1, negative 1. And you can always check this doing left side, right side for both equation 1 and equation 2. And we've seen that in our other videos, so we won't do that right now. Okay, so let's go down a bit and let's do another example. Let's say, for example, I have the linear system 5m plus 2n is equal to negative 2, and I've got m plus 3n is equal to 10. So again, I've got two equations, equation 1 here and equation 2 here. And notice I use m's and n's instead of x's and y's. That is just fine. We treat it the exact same way. Now, I said before we want to decide which one we're going to eliminate, we look at the two variables as they match up. We look at the m's and the n's. Taking a look at the m's, the coefficients don't match up. But taking a look at the n's, the coefficients don't match up there either. So what we need to do is we need to make the coefficients match. And I can do that by multiplying one or both equations by some value that's going to make them match. And as long as I multiply all parts of the equation, I'm not changing what the equation is worth. So it looks like the easiest thing that I can do here is I can take equation 2. I'm going to take equation 2 and I'm going to multiply it by 5. And if I take equation 2 here and I multiply it by 5, everything now gets multiplied by 5. So I'm going to have a 5m plus a 15n. And that's going to equal 50. So notice that I multiplied this by 5, this by 5, and this by 5. And it turns out to be the same equation, it just looks a little different. Now my m's match up. So I'm going to rewrite equation 1 below it. So this is now equation 1, 5m plus 2n equals -2. I've just taken that equation and rewritten it down there so I can work with them together. And now I have to decide if I want to get rid of these m's, do I want to add these two equations together or do I want to subtract them? And what I'm going to, let me just write equation 1 in here. There we go. And of course, if I have 5 m's and I'm trying to get rid of 5 m's, I would have to subtract. So I would take equation 2 and I would subtract it from equation 1. And what that's going to give me as an answer is 5m minus 5m is going to eliminate my m's. 15n subtract, because we're subtracting, 15n subtract 2n is going to give me 13n's. And 50 subtract -2, watch that double negative there, is going to give me 52. And now we're going to divide both sides by 13. And of course, then n is going to equal 4. Okay, so I now have my n value. What I'm missing is my m value. So I'm going to take n equals 4 and I'm going to plug it back into either equation 1 or 2 or the changed equation. It doesn't matter. Plug it back into any one and it's going to give you the result. So I'm now going to take n equals 4 and I am going to plug it back into, it looks like the original equation 2 might be the easiest one to play with. But again, you'll get the same result if you put it in any one. So I no longer have to write n. So the m is what we're looking for, plus 3. And instead of writing an n there, I now know that my n is equal to 4. And that's going to equal 10. And m plus 3 times 4 is 12 is equal to 10. I'm going to subtract 12 on both sides. 10 subtract 12 is -2. And therefore, the solution is that m is equal to -2 and n is equal to 4. And again, you can check that using left side, right side.